recording on again. And again, in the, we always want to be sub-metering, tracking, monitoring, looking for trends, looking for problems, right? If there's a sudden increase in water consumption, right? Maybe there's a leak someplace. Certainly in our outdoor irrigation system, it's quite, the person cutting the grass or with the weed whacker, whacks off the top of the sprinkler head. Right now, water's shooting all over the place, right? That'd be something that you might track through your monitoring program. Right, again, xeriscaping, that's planting limitation of turf grass, using water efficient plants. And obviously there's going to be maintenance involved in that. See, I took this content from here and kind of highlighted the key elements. But again, xeriscaping is water efficient landscaping or low water use landscaping. We don't see this much in our part of the world yet, but in other parts of the country, we have reclaimed water, right? So we talked about our waste treatment goes to Stickney, and the effluent from Stickney is discharged into the sanitary and ship canal and goes downstream to the Illinois River and into the Mississippi, right? That's what happens to our wastewater discharge. But potentially that wastewater discharge could be reused, right? It could be piped around. Again, when I was making up this lecture or cleaning this lecture up a couple of years ago, I found some interesting pictures about, purple fire hydrants and that sort of thing, right? Again, purple is kind of the color for reused or reclaimed water. Less likely, we haven't really gotten here yet in our part of the country, but certainly in Southern California, perhaps in Arizona, you're going to start to see this sort of thing. Right. So again, in reclaimed water, we have to look at how, the treatment process that water has undergone. I think we still have a bit of a stretch to envision us, using reclaimed water for potable water use, but certainly could be used for, irrigation and other uses. Right, again, this is kind of reclaimed water. This is still emerging technology, right? We have to treat that water through a tertiary treatment process. Right, I think what's, again, the water, the outlet of our wastewater treatment is being discharged, as I say, into the sanitary and ship canal, and somebody downstream from us may be taking some of that water in. Okay, so again, here's our scorecards. Sorry, I need to learn more about this subject area, about reclaimed water, especially because it's less common in our area than it might be in other parts of the country. So again, here's our BD&C scorecard for water efficiency. And again, sorry, I should zoom in a little bit here. I do have our prerequisites, what's required: outdoor water use reduction, indoor water use reduction, metering. We have, again, prerequisites and credits. So this would be the scorecard for BD&C for new construction. Again, here is our scorecard for O&M. Same sorts of, let's make sure I got the same thing. Yep, here's O&M. Same ideas, right? You see a lot of potential credits for indoor water use reduction in LEED O&M. So again, in my past life doing O&M projects, we got tempted to do a retrofit project and go after those 5 points. You know, that's where we got ourselves into trouble with you know, trying to do a low water use retrofit on that 3.5 gallon per flush china, right? That was a not a successful project. Right, again, here's, I just pulled off some information about the BD&C prerequisite for outdoor water use reduction. So again, you know, if you were going after this credit, actually, if you're going after BD&C, you got to be aware of the requirements of the prerequisite, because that's something that you have to do. Any questions? Okay, we got a few minutes left. Let me jump into one other lecture here. We won't get there we go. Sorry about that. Either my computer's slow today or Blackboard is cranky today. I don't know. Anyways, we're going to have a couple lectures here. I would say a few minutes left tonight, and probably 2 more weeks related to LEED energy and atmosphere. Again, I mean, this is my swim lane. This is what I do for a living, right? So I have a lot of information about energy and energy conservation, right? This is my job. This is what I do. So we will start on this, and we'll work on it some more next week. So we're going to talk a little bit about some characteristics, some material properties, some characteristics of heat and temperature, U values and R values. Like, these are U values and R values are a way that we characterize the properties of materials or properties of building materials and their ability to resist the flow of heat. Right, things you might have learned in high school science class had you been paying attention. Right, heat is a form of energy. Temperature is what we use to measure heat. And heat flows from areas of higher temperature to an area of lower temperature, right? So in the case of a building, a day like today, a little cool outside. So this morning I had to turn my heat on, right? Because it was, what, 45 degrees or something outside. I want to have trying to warm my house up to 68 or 68-ish, right? Because all that heat in my house snuck out overnight through the walls and the windows. So I had to make up for that. So heat is going to tend to move from areas of higher temperature to an area of lower temperature. Right? Heat transfer is that process, right? Energy moving from a warmer object to a cooler object. Right? Our goals when we insulate is to slow down or reduce, control that heat transfer. When we insulate, when we design a high performance building envelope, we're trying to slow that heat transfer process down. And we have, again, high school science class, 3 different types of heat transfer: conduction, that's direct contact. Convection, is through the movement of a fluid being air or water, a liquid. And radiation is transferred by electromagnetic waves, right? Like that's the sun shining on your face on the day, or the the warmth from your fireplace or your campfire, right? Right, again, here's conduction, convection, and radiation. 3 different types generally of heat transfer. Here are those same types of heat transfer in the context of us trying to warm a house, right? See here it's 70 degrees in the house and 30 degrees outside. So we have conductive heat losses through the walls and roof. We have some convection taking place inside the house, right? The heat transfer via the air that's circulating off that heater. And we have some radiation heat gain, and right, in this case we have the sun shining in the window and acting to warm up the air inside the house, right? 3 types of heat transfer. We'll come back. We'll start again here next week. Again, this is my geeky engineering world, right? This is how we design and we calculate these things, right? So Q is the amount of heat transfer, and U is a property of the material. So what we're trying to do is add more insulation to raise that R value, or have a more efficient window or skylight to lower the U value, to reduce the amount of heat flow, right? Ultimately, that heat that gets lost has to get made up by some energy source, a boiler or a furnace. That boiler or furnace requires a fuel that's emitting carbon dioxide into the atmosphere. We're trying to reduce that. So one of the levers that we have to reduce greenhouse gases is to make the envelopes of our buildings more efficient. And I think I'll leave it at that for today. Any questions, folks? Okay, again, I am going to do my best to get your midterms graded tomorrow. I'm actually going to visit my grandchildren in Denver on Wednesday, so I'm going to try like heck to get this stuff done so I don't have to lug my computer around with me when I'm supposed to be watching my grandkids. And next week we'll continue with this, and also any of you who have submitted your your presentations for your book reports, your knowledge sharing will give you a chance to make those presentations as well. Okay, well, thanks everyone for a good class, and we will see everybody next week. Thanks everyone. Good evening. You are welcome, Mac. You're very welcome, Ayana. Thanks for a good class.
You know what? I just have one question, Mr. Becker, and maybe
Sure,
you'll
of
go
course.
over this next week. I'm sorry to hold you. But
No, no problem at all. I'm here. I'm here to answer your questions, Ayana. So no reason, no need to apologize.
no, and maybe we'll talk more about this next week with the heat transfer and the site selection and everything. But I guess because what I'm learning is like when it comes to them applying solar panels to roofs, that the industry was the standard is just that they apply them to the south facing side of the roof for the greater like solar absorption or something, right?
Yes, yeah. Obviously, the sun moves across the sky in the south and out of the north. So yeah, we generally put solar panels on south facing or close to south facing roofs.
So if there was a new construction or a new build, and if a site could be selected where, let's say, you can choose if if the house was going to be facing, whichever direction, would you want the house to be facing south? Like, would the preference be for the house to receive all of that sun during the day and um so that it can stay heated and it can maybe offset some of the cost of the heating because you're like heating it from the radiation, I guess, of the sun all day.
Yes, yeah, no, good question. Yes, that would be ideal if we have the choice, right, to orient the building facing south. And I think we'll touch on this in a couple of weeks. But yeah, we both in orientation and the disposition of spaces, right? We want to have the living spaces facing south and maybe the other spaces facing north where the light and the heat gain isn't that important. But yes, yeah,
Okay.
if we can choose, we certainly want to do that. We don't always get the choice, right? We may,
Right, right. No, we don't
right?
always
And,
get the choice.
but we also can make the building envelope very efficient so that the gains are the amount of heat that we lose is relatively low and orientation becomes less important, right? That's
Hmm.
one of the things, one of the levers that we have. But yes, all other things being equal, we want to try to orient toward the south.
Okay, okay, just checking. Well, because one of my first, as in my real estate career, like one of my first, I guess, special courses or the designation courses that I took and got a certification in is this green houses and these green builds. And no, I'm really looking forward to this lead exam thing because I think it will all like it touches so much stuff that I'm kind of familiar with, but I just downloaded the lead handbook. And I mean, I have the book and everything now, but there was a really nice lady. I don't know. Have you ever heard of Pamela Brookstein? She
Name doesn't ring a bell, no.
okay, yeah, she works for some company. She's in Oak Park. She's based in Oak Park, and she was my instructor for this the National Realtors Association, like this green designation course. And yeah, she taught us all about, these the building envelopes and these blower doors and all this stuff. And yeah, just a lot of stuff that overlaps here. So just looking forward to it. That's it.
Well, sounds good. Sounds good.
Okay. All right. Well, you enjoy your weekend, your trip.
Thank you very much. You as well, and have a good week, and we'll talk to you again soon.
Okay. All right. Thanks.
Bye.